Hello everyone. Today we are going to talk about how to rule the world without resources. Mystic topic. What I mean. Today programmers have to develop very complex product. Maybe something is familiar or not. There is a lot of frameworks, libraries, databases. We have to deal with all those things. Many external resources in our product. So I have a question. Have you ever worked with any complex product? I bet you do. My name is Borysław Bobulski. I developed one of this kind of product in Motorola. I would like to share with you my experience of extending IMW system. So, let's look live. What do you have to do? So we have a complex system. How to extend the system with speed and confidence? How to add new functionalities to code which looks like this? So it is a mess, How to write something and add new functionalities? How to test first draft of our code? There are two ways, very popular ways. First of all, we can test our changes on real system, which looks like this. You just need to take last changes from developer branch, configure all virtual machines, install all resources, all databases, all parts of our product, set DNS, set appropriate certificates, reconfigure, and voila! We can test our changes. A lot of work. Sometimes your changes are not work with changes which are introduced by other person. Sometimes you cannot even raise your service. So, what to do in this case? Developing product in that way is very, very slow and very frustrating. So, let's look. Here we have some resources. Here resources, other component resources. How to configure this? How to run this product? Of course, we have unit testing. Yes, we have unit testing. We can use unit tests. It is a good solution. With unit test, we can check some parts of our code. But still, we have a lot of dependencies. In unit test, we use mocks, we use fakes. This is not a real flow. This is not a real dependency. It is good to have those layers, those unit test layer, but we need more confidence that we do not destroy our system when we introduce our changes. So, our goal is faster development, tight feedback loop, increased testability, and increased extensibility. Actually, there is a solution. We can provide hexagonal architecture, which is also called ports adapter architecture. From this point, everything will change. We did this to services we developed, and it was the best decision ever. Now, in very short time, we can have fast feedback. We can be pretty sure that our changes our changes in code do not destroy everything. How to do this? First of all, we need to switch to solid architecture. Solid, I mean following all those agile, solid, Uncle Bob principles, single responsible principle, open close principle, etc. At least you must use abstraction, dependency inversion, and do not use object in place where they are creating. So we move those elements into solid code, and what is this? You must create abstract gateways to have hexagonal architecture. Here we have ports. Ports are abstract gateways used to communication with our component. There are external resources like databases, file system, system time, TCP messages, and etc. Everything which comes from real world. And code which work with real world is moved to adapters. Yeah? And this is a hexagonal architecture. And why hexagon? Because it's a nice shape, Hexagon need initialization to receive set of adapters. Your application in hexagonal architecture must create a set of adapters and provide them to those hexagons. So this is our component, this is adapters layer, and this is our application. An adapter is something which allows you to enter, exit the hexagon. And this is another image where we can see how to use hexagon architecture to test. So, here we have a driver, it inits adapters for tests. Here we have components layer, it is our domain. And we must remember that this hexagon works with application code and with test code. Here we have some mocks, and here we have predefined our random values. Nothing changed here. Domains is the same all the time. Okay, let me tell you about using those driver in component test. Here we have a component test. This is a real example. Here we have 3 sections. And first of all, we initialize all basic stuff. We initialize our driver. We start our driver, and then you can see here some kind of DSL, domain-specific language, which allow us to better understanding of our component tests. Here we have a driver which initialize all adapters, and you can read this. So member is for member, which is authorized for every group, and successfully affiliated to this group, we subscribe for all events, and we check receive notification. And this is abstraction which hide all those basic stuff like assertions, mocks, etc., etc. So, this is everything I would like to tell you about using hexagonal architecture and component tests. So, if you have any questions, please